Let's talk about some more things that people often have trouble with. This could be in chapter 5.4, it could even be earlier in chapter 5.1. How about the integral of 1 over t squared dt? What do you think? Well, what I would do is rewrite it as t to the negative 2 dt, and then the integral of t to the negative 2 is t to the negative 2 plus 1, and 1 over whatever we just wrote. What is negative 2 plus 1? It's negative 1. So we're getting 1 over negative 1 t to the negative 1. We'll throw in our plus c. So that's the good way to do it. And you can check that by taking the derivative. What some people try to do is to say that they see the t squared and then they turn that into t cubed. So they say, and then it's over something, it's 1 over that, so they write it 1 over t cubed, and then they write a 1 over 3 out front. That's if you check that by taking the derivative, you don't get what you would hope for. You don't get the 1 over t squared. Let's see, other people might say that they know the integral of 1 over x dx is log of absolute value of x. So they would then say, well, now I have a t squared instead of an x. So we would then say 1 over t squared dt would be log of 1 over t squared, figuring whatever's in the denominator here, you just put in the absolute value there. But again, if you take the derivative, you don't get that works. So that's one thing to be careful on. Another one seems simple, but is maybe a little subtle. How about the integral of a dx? And a is a constant. What I would do is move the a out in front. Well, you don't have to, but that's one way to do it. And what you're left with inside is a 1. And then you'd say, what's the integral of 1? It's 1 is like x to the 0. So the integral of 1 is x to the 1. You could say 1 over 1 if you want to. Or you could just say the integral of a dx is just a times x. You could say the integral of a constant is that constant times the variable of integration. So those are both good. Where you have to be really careful is saying, well, any variable I have here, if it's kind of to the 1, I'm going to make it to the 2. So it's tempting to say it's 1/2 a squared. That would be the answer if this was x dx, but a is not a variable, it's a constant, so we don't change the power on it and multiply it by 1/2 or anything. So that's something else to be wary of. Yet another tricky spot, the integral of 2 to the x dx. So some people might say, is that equal to 1 over x plus 1, 2 to the x plus 1? Like, can I add 1 to the exponent and then also write that new exponent in the denominator? If you check that, it doesn't check out. So what do? We need a rule for when the power is the variable and the base is constant. So here we tried using the constant power rule, even though the power is not constant. So let's say, it's called the power rule, but it really should be called the constant power rule. That doesn't apply. What I need is a constant base rule. Constant base and variable exponent. So what do we know about integrating exponential functions, we know that integral of e to the t dt is e to the t plus e, where e is a constant and t is a variable in the power. So what can we do with that? Can we just apply it here? Well, we could guess that the integral of 2 to the x dx is 2 to the x. You'd check it by taking the derivative. What is the derivative of 2 to the x? So here I'm saying 2 to the x because that's what my answer was. So I'm putting that inside the parentheses there. And that is 2 to the x times log 2, if you remember the formula for something to the x other than e to the x. So that didn't work. But we were only off by a constant, so maybe I can anticipate that constant being there and have something ready to cancel it out. So we're going to adjust our guess and say the integral of 2 to the x dx maybe is equal to 2 to the x times something that will cancel the log 2 when I take the derivative. So how about 1 over log 2? And let's check that. 2 to the x times 1 over log 2. I can drop the plus c when I'm taking the derivative. So that would give me 2 to the x times log 2 times 1 over log 2, which works out to be exactly 2 to the x. Remember, I'm multiplying by 1 over log 2 here, which is a constant, so I don't need the power rule. I can just use the constant multiplier rule. So when you're integrating 2 to the x, you end up, with a 1 over log 2 factor, which is the opposite of what happens when you're taking the derivative of 2 to the x. So maybe not a surprise, but every now and then it pops up.